Okay, this is week 4, and this is for our pre-algebra classes. So remember that everything will still be located under the classwork tab in your Google Classroom. Okay, and you will still have a bell ringer for Monday, Tuesday, and then Thursday and Friday each week. So that is the first thing that you should do is come in here, click on your bell ringer form. Again, it should have your email address at the top, and you should only answer Monday on Monday. And then go down here and hit that purple submit button. If you want to pause the video at this point so you can go ahead and do your warm-up, feel free to do so. Okay. Now, we have been posting the slides every single class period or every single day that we've been in session. Okay, so on your slides for today, if you've gotten this video, you can tell that it was attached to where the slides will be at. If you want to open up your slides at the same time as your video and split screen, you can definitely do that, or you can just watch the video and open up another tab if needed. So I'm going to go ahead and open up the Google Slides for today. We are starting a little bit of a different lesson than from our regular math classes. Remember, pre-algebra does cover some 8th grade content, so that means we are going to have to move at a little bit faster pace than some of our other classes. Again, you should have done your bell ringer for today. Again, if you did not, you can pause at this point, and then we will go over it in just a minute. So for your bell ringer today, it said, what is the difference between a rate and a unit rate? So a lot of people really were messing up on the vocabulary in our topic A quiz. And so that's why we put this back on here. So remember, one of the most important things, the rate still there, but this word unit. Okay, that should indicate to you that your denominator needs to be per one item. Okay, so a rate is only per one. That's not right. Wrong one. It's a unit rate is only per one. Think of that word unit. So you should have checked the second one for your answer for the bell ringer today. So very close, but they are not the exact same. That unit rate has to have a denominator of 1. So let's go ahead and get into the notes for today. Okay, we do have just a little bit of notes before, and then we're also going to go through some problems with you guys using Cami while you get to take notes. And so that way you can go back and look at them anytime you want to. So it said, here is a table comparing the amount of flour used to the amount of cookies. So you can see that for 1 cup of flour, that makes 2 dozen cookies. For 2 cups, 4, 3 to 6, 4 to 8. So our first question says, is the number of cookies proportional, okay, to the amount of flour used? So remember, if you're looking at a table, in order to tell if it's proportional or not, we're always going to do our y value divided by our x value. And these numbers are actually really easy. So if I start with this first row in the table, my y value is 2 and my x value is 1, so I get 2. And then you just go down. Remember, you have to check the whole table. 4 divided by 2 is 2. 6 divided by 3 is 2. 8 divided by 4 is 2. So you are looking, if something is proportional, that all of them will have the same value when you divide. So if you explain why or why not, you can just say that the constant of proportionality, or the constant, is 2. And then it says, what is the unit rate of cookies to flours? And what is the meaning in the context of this problem? Well, we know that the unit rate is the same thing as the constant, but now it says, what is the meaning? So 2, and remember our y value is on top, so that's talking about 2 dozen cookies. And that's for every 1, and our x value is on the bottom, so that's talking about cup of flour. And remember, that's what we just talked about. That unit rate or constant of proportionality is going to have that denominator of 1. You're always going to want that. Okay, same problem, but moving on to a graph of it. Okay, and we might have to flip back and forth here. So let's go ahead and look at the table, and we'll write it on this slide so you know. So we have 1, 2, 3, 4 for our x values and 2, 4, 6, 8 for our y. So I'm going to copy that down for us. So our x and our y, we had 1, 2, 3, 4, and 2, 4, 6, 8. This was the cookies by the dozen, and this was the flour by the cups. So remember, our x value is down here at the bottom, and so we'll always want to label. And again, the flour was by cups. And then our y value is on the side, going up and down vertically, and it's talking about cookies, and it's by the dozen. So now we just need to graph it, and I'm just going to use each point for 1. So 1, 2, 3, 4, 5. And then our y values can also go up by 1. 1, 2, 3, 4, 5, 6, 7, and 8 is the highest we go. And so graph, remember x is the amount you go over, and y is the amount you go up. So the point 1 goes over 1, up 2, and then over 2, up 4, over 3, up 6, and over 4, up 8. And you do want to always connect these values to see if it's a straight line and that origin. So does the graph show the two quantities being proportional to each other? I just kind of gave that away. Yes, it goes through the origin, which is, remember, one of the things that we have to have. And the second thing that we have to have is a straight line. Now remember, that line really goes on forever, but we'll just stop it at that middle. And then the last one says to write an equation that can be used to represent the relationship. So we know our equation is usually y equals kx. And in this one, our constant is 2. So we're just going to replace k with 2. So y equals 2x. So basically what we're doing is putting back what we went over last week all together when we talked about a table and a graph and an equation with a constant of proportionality. And that's what we just did. So the next example, it says, what are the coordinates of the highest point on the graph? What do they mean in the context of this situation? So for this one, it's asking us what this one is right here. And so we have to understand how to read it. So much like our other one, it's still dealing with cookies by the dozen, but this time instead of flour, it has sugars, like cups of sugar. So let's read it. It's basically saying if you go over here to my y value, okay, and these go up by 1, so 21, 22, 23, 24. For 24, and this is dozen cookies, so for 24 dozen cookies, I need, and then again, if you want to draw your line down, that would be going up by 1, so 16. I need 16, and it's cups of sugar. So reading a graph is very, very important. So 24 dozen, remember these are y's, and 16 cups of sugar, which is my x value. And you could do that with any of these points. Okay, this would be 12 dozen cookies, 4, 5, 6, 7, 8 cups of sugar. This one right here would be 6 dozen cookies for 4 cups of sugar. Make sure you can read this chart. Okay, part B, it says Grandma has 1 remaining cup of sugar. How many dozen cookies will she be able to make? And what do we call this point? So if I'm looking at 1 cup of sugar, I'm right here on my X. So I'm going to go up, and at that point, what is this value right here? What is my X value at this point on the graph? And so it's kind of hard to see, okay? So let me erase that so you can get a good look. Again, we're looking at that dot right there. And again, if I go over That's basically in between the 1 and the 2. So she would be able to make 1.5 dozen cookies. And it says, what do we call this point? So remember, wherever my x value is 1, since a unit rate has a 1 as a denominator, that would be our unit rate, or what we call a constant of proportionality. So for every 1.5 dozen cookies, we need 1 cup of sugar. All right, and C. It says, how many dozen cookies can Grandma make if she has no sugar? Can you graph this on the coordinate plane? And what do we call this point? So think about that. How many dozen cookies can Grandma make if she has no sugar? So that would be down here, 0 cups of sugar. Well, that means she can make 0 dozen cookies. Okay, so 0 cookies. It says, can you graph this on the coordinate plane? Yes, you can. And hopefully you remember it. It starts with an O. That's what we know as origin. It's the point 0, 0. And we always want a proportional graph to go through the origin. So keep that in mind. So again, more about interpreting graphs today than tables. Now, we have a cute video for you. It says, what do you think the unit rate of a sloth might be? So here's a little clip from Zootopia.
Well, I was hoping you could run a play for us. We are in a really big hurry.
Sure. What's the plate?
29 T
Number.
29 THD 03.
Two. 9.
THD 03.
T.
HD 03.
H.
D 03.
D.
03.
0.
3.
Hey, Flash, want to hear a joke?
No!
Sure.
What do you call a three-humped camel?
I don't know. What do you call a
3-humped camel.
3-humped camel?
Pregnant.
Yes, very funny, very funny. Can we please just focus on the test?
Hey.
Wait.
Priscilla.
Oh, no! Yes? Flash?
What do
No!
you call
A 3-humped camel? Pregnant! Okay, great, we got it! Please,
humped?
Coming through. This is Officer McCorn. We got a 1031.
I got dibs! Officer Hawk, I am...
So pretty funny. As you can see, the unit rate of a sloth might be very, very slow. It would not go very fast. And that's what our next example has, is it's talking about a sloth. Okay, so speed of a sloth. Okay, our x value is time in minutes, and our y value is in distance per feet. So it says, is this graph proportional? So hopefully, again, just by visually looking at the graph, you know yes. Okay, because it's a straight line. And it also goes through the origin. Remember, those are two important things of a proportional graph. The second one says, what 2 points must be on the graph if the two quantities are proportional? So we know the origin, okay, which is 0, 0. And the other one is whatever our unit rate is. So that's when the x value is 1, and then whatever that y value would be, which is the unit rate number, the constant number. So on this one, it says C, what point represents the unit rate? So let's go over here and look. If this is the x value, remember we want that to be 1 for the unit rate. So if I follow this up, okay, right here would be where the unit rate is at. So that would be 1 for my x value, and my y value is 6. It says write an equation that represents the proportional. Okay, so remember y equals kx. That number I just found was 6 for my constant. So y equals 6x. So now that we know he can go 6 feet, because that's the y, in 1 minute, we're going to use that information to answer E. So it says Miss Phoenix and Miss Bratcher's room are 28 feet apart. How long will it take the sloth to visit each teacher? So basically, how long will it take to go from Miss Bratcher, my room, all the way down to Miss Phoenix's room? Okay, so if it's 6 feet in 28 minutes, or 6 feet in 1 minute, if he had to go 28 feet, think about whether you'd be multiplying by 6 or you'd be dividing by 6. So hopefully you have figured that out. You will be dividing, okay, because I'm trying to find my minutes. So 28 divided by 6 is going to give you the amount of minutes. So let's figure that out. Again, you can use your calculator. 28 divided by 6 would be about 4.67 minutes. So if he was trying to transition at our school, we have 4 minutes in between classes, he would not make it in time to his next class to start, traveling from my classroom to Miss Phoenix's classroom. All right, so we're going to do just a few more examples with Cami. So we did this last week, and again, it will be listed as an assignment, but it won't have a due date or it's not worth any point values. This is just so you can practice along with us and actually see the graphs and write on the Cami yourself. So it is using Cami. We're gonna do an I do, you do in class. So please make sure you're being attentive. Make sure that you pause this video if you need to in between each one. So that way you don't get the answers ahead of time and you actually try these problems on your own. So I will show you where the Cami is. All right, so I would go back to the Google Classroom. Okay, and you're still on Monday. And it's right here. It says Monday 2, Cami Notes, Lesson 10. So remember, you don't really need the directions over here. You want to open the PDF. You have to hit the blue button that says Open with Cami. And then it should open for you. Okay, and we're just going to follow through this. Again, you can always see how many questions are our first by looking at it. We're going to do the first one together, and then we're going to have you do the second one. And then we'll do the third one together. We'll have you do the fourth one, and we can do the last one together. Again, at the very end of this, yours over here will have a turn in button. Okay, if you want to write your name at the top, you can. You don't have to because it collects it by your email. But it doesn't matter to us if your name is on it. We'll get it. So number 1, it says the graph to the right shows the relationship of the amount of time in seconds to the distance in feet run by a Jaguar. It says, what does the point 5 to 90 represent in the context of this situation? So if you want to use your text button, that actually may be much easier. Okay, and you can always change the color of your writing as well. So what does the point 5 to 90 represent in the context? So we know that the point 5 to 90 is right here. 5 first, because that's the x value, to 90. So basically what this is saying is in 5 seconds, and we're talking about a Jaguar, the Jaguar can go 290, and it's in feet. So same thing for B. What does the point 3, 174 mean? So instead of 5 seconds, in 3 seconds, the Jaguar can go 174 feet. Okay, and it says C, is the distance run by the Jaguar proportional to the time? Explain why or why not. So again, if you're looking at a graph, there's two easy things you know if it's proportional, is if it goes to the origin and if it's a straight line. And it has both of those things. So yes, it goes or it starts at the origin and it is a straight line. So the last one says write an equation to represent the distance run by the Jaguar. So I'm going to increase this so you can see it a little bit better. Okay, so if you're looking at this, remember wherever our x value is 1, that's our unit rate. And our y will give me that k value in our equation. So if I'm right here, this point is telling me right here, this 1, 58. It's telling me that when my x value is 1, which is what I want, then my y value is 58. So you know your constant of this entire graph and this proportion is 58. So instead of y equals kx, it should be y equals 58x. Okay, again, that where x value is 1, okay, which should be down here further on the graph, that is where your constant is and where you can figure out that number. All right, so at this time, I want you to do number 2. Again, if you're watching the video, I would like for you to pause it and try it first, and then we'll go over the answer. So it says Champions t-shirts sell for $22 each. It says what point or points must be on the graph for the quantities to be proportional to each other. So we talked about this in our Google Slides. The first point we want is the origin, which is the point 0, 0. Okay, and we also want the unit rate, which is wherever our x value is 1, our unit rate number would be the y value. So it says, what does the ordered pair 5, 110 represent in the context of this problem? So you might have thrown you off just a little bit because there is no graph like the other one. But think about it. Our x is 5 and our y value is 110. And money is always on top. So that's that y over x. So that means that 5 shirts cost $110. Then it says, how many t-shirts were sold if you spent a total of $88? Well, if one shirt cost $22, then how many shirts would cost 88? Think about, are you going to multiply by the constant of 22 or are you going to divide by the constant of 22? Multiply or divide. Remember, if I need my y value, I multiply. Okay? And we don't need that. Our y value is money and we already have it. So I don't multiply this time. I will actually divide by my unit rate, which is 22, because it says that Champion t-shirts sell for 22 each. And 88 divided by 22 is 4. So 4 t-shirts would be $88. And again, 22 times 4 is 88, so that makes sense. Okay, number 3. It says the graph represents the total cost of renting a car. The cost of renting a car is a fixed amount each day, regardless of how many miles the car is driven. So again, what does the ordered pair 4, 250 represent? 4 is our x value, so down here represents the number of days. So for 4 days will cost, total cost is our y value. 4 days will cost $250. It says, what would be the cost to rent the car for a week? So a week is 7 days, full 7 days. Again, when we looked at our Jaguar example up here, we know that this one where the x value is 1 is our unit rate. So that means 58 feet in 1 second. So in order to figure out how much it would be for a week, we probably want to know how much it costs for 1 day first. And if you noticed in this diagram anywhere, it does give us that point again. Remember, where x value is 1, the y value is the constant. So 62.5 would be $62.52 per day. So $62.50 per day. And remember, it's 7 days in a week. So if it's 62.50, we want to multiply that number by 70. So multiply by 70. Multiply by 7 days a week. Okay, and if we get that, 62.50 times 7, going to be pretty expensive, is $437.50. So think about the difference between if I had my y value and versus the x value, whether or not you're going to multiply or divide. If I need my y value, I multiply, which is right here. If I need my x value, I will divide by the constant. So if I need my y, I multiply. If I need my x, I divide. If I need my y, I multiplied. If I need my x, I divide. All right, number 4. It says that Jackie is making a snack mix for a party. She is using cashews and peanuts. The table below shows the relationship of the number of packages and the number of peanuts. So remember, if it's not labeled, the first one is always X and the second one is always Y. It says write an equation to represent this relationship. Well, first off, we need to see if it is proportional or not by dividing our Y by our X value. So I'm going to do this over here to the side. And again, these numbers are pretty small. You don't really ever have to do this 0.00 because we know that's just the origin. So start with this first one. 2 divided by 1 is 2. Okay? Then if you do the next one, 4 divided by 2 is 2. 6 divided by 3 is 2. And 8 divided by 4 is also 2. So because those are all the same, we know that the constant is 2. So my equation would be y equals 2x. And then it's asking us to just describe the ordered pair. Remember, the x value is first and the y value is second. So my x, if you don't know what that's talking about, it tells us in the table. So that means for 12 packages of cashews, I need 24, and then our y value is talking about cans of peanuts. Again, making sure you understand what the problem is talking about is very, very important. All right, and then the last one is number 5. Number 5 is the last one. Okay, the following table shows the amount of candy and price paid. So remember, the first one is always X, the second one is Y if it's not labeled, and we know money is always a Y value. So we have 5 different questions here. A says, is the cost of candy proportional to the amount? So we need to divide, and again, I'm going to use my pen here. We do our Y value divided by the X value. So 5 divided by 2, 7.5 divided by 3, and 12.5 divided by 5. And you're more than welcome again to use your calculator. 5 divided by 2 is 2.5. 7.5 divided by 3 is 2.5. And 12.5 divided by 5 is also 2.5. So because these are all the same, we know that our constant is 2.5. So yes, the constant is 2.5. All right, and then it says write an equation to illustrate the relationship between the amount of candy and cost. So we know instead of y equals kx, we just replace our k with the constant. So y equals 2.5x. Remember, k can be a decimal. Now it says using the equation, predict how much it will cost for 12 pounds of candy. So remember, our candy is our x value. So if I plugged in 12 for x, that doesn't mean 2.512. When a number is next to a variable, it means to multiply. So 2.5 times 12 is $30. We know how that much it costs now. Okay, and then it says what is the maximum amount of candy you can buy for 60? Okay, so again, this time instead of multiplying by my constant, I'm going to want to divide by my constant. So 60 divided by 2.5 is going to get you 24. And it says amount of candy. So remember, we're talking about in pounds. So 24 pounds of candy. Just quite a bunch. And then it says to graph the relationship. Okay, and so a lot of people think that it can't be done just because there's decimals, but it can. Okay, whether you want to go by 0.5 values or by 1, I'm just going to go by 1. But first off, let's label the table. So we know this is your x, which is the candy, and it's done in pounds. Actually, let me scoot this down. So candy is in pounds. And then our y value is always on the side. And our y value is talking about the cost, and it's in dollars. So if I go up by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then for cost, I at least need to get to 13. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So remember, when you graph, it is x comma y. So if our x value is 2, you go over 2. And then our y matching is 5. Then the next point is over 3, up 7.5. So be careful where you put that. And then over 5, up 12.5, which is in between 12 and 13. And again, for you guys, you might have to either increase the thickness or decrease the thickness of your dot. And you should hopefully see that it goes to the origin and is a straight line. Okay, there is no other assignment for you today. These notes you can keep. Remember, yours should have a turn in button over here on the side. Make sure you press turn in so you can keep the notes and look at them for what you have wrote. Other than that, we will see you Tuesday for your class.